Sarah, you don't need not to write this one. Sarah, you are not going to write this one. You have to memorize. I am going to listen from you.
Okay, sir.
Yes, Samia, Hanan, Lar, anyone who has memorized? Heather, memorize it fast. Memorize it.
Done, sir.
Hanan done? Okay.
Done.
Then close your eyes and start speaking. Means I want to listen. Having your eyes closed.
So elements are chemically combined together and in a ratio of mass, and the elements of mixtures are combined physically with non-proportionate properties, and the constituent of compound don't show their properties, and the constituent of mixtures show their properties. The constituents of the compound cannot be separated through simple methods like filtration, evaporation, boiling, freezing, etc. They can only be separated through a chemical method. Meanwhile, the constituents of mixtures can be separated through simple methods of filtration like like, evaporation, boiling, and freezing. Uh, the compound has a fixed formula, fixed boiling point, and a melting point. Meanwhile, the mixtures does not have a fixed uh, formula, boiling point, or melting point.
Okay. Yes, you, Bharti.
Yes. Compounds are physically combined and they have a fixed proportion.
Physically combined compound. No?
Chemically combined,
Okay.
chemically bonded, and they
What?
have a
Why?
fixed proportion.
In compounds, elements are chemically bound.
Elements are chemically bonded with a fixed proportion.
Okay.
In mixtures, they are physically combined and they do not have a fixed proportion.
Okay.
Compounds, their constituents do not show the properties. In mixtures, the constituents show the properties.
Okay.
In compounds, they cannot be separated by physical methods like evaporation or filtration.
Okay. Okay.
Only
Good. Yes, you, Samia. The next points.
So compounds cannot be separated by any physical method like evaporation, boiling, or heating. Meanwhile, mixtures can be separated with physical methods such as boiling, evaporation, or filtration. And compounds have a fixed formula, and meanwhile, mixtures do not have a fixed formula.
Okay. Yes, you, Saad. Tell me, what is
Yes, sir.
remaining?
Yes, in a compound, the elements are chemically combined together in a ratio by mass. In a mixture, the elements are physically combined together in a non-proportionate manner. Uh, in a, in a compound, uh, in a compound, the constituent does not show its properties. In a mixture, the constituent shows its properties. In a compound, the constituent cannot be separated by physical methods such as filtration, cooling, boiling, etc. In a mixture, the constituent can be separated by filtration, cooling, boiling, etc.
Okay. 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 Yes, you, Muhammad Haider. Hmm?
I didn't write.
Why didn't you write? Why didn't you remember?
Sir, because I was in vacation, so I did not memorize anything.
So I give you that, I give you the time right now na, to memorize. I explain you. I
was
give you the time.
memorizing, sir. Yeah, not complete.
Yes, you Hanan.
In compounds, it is chemically in compounds the elements are chemically uh,
Yes. Why have you turned off your camera?
in compounds the elements are chemically combined together with a fixed ratio and mass, while in mixtures it is physically combined together with no fixed ratio or mass. In compounds, the constituents does not show its property, while in mixture, the constituent shows its property. In compounds, the constituents that constituents cannot be separated by physical method like boiling, evaporation, and all, but in mixtures it can be separated.
Okay. Very good. Yes, you, Sarah? Sarah Khan.
Sir, in compounds, the elements are chemically combined together in a fixed ratio, whereas in mixtures, the elements are physically combined together in a non-proportionate mass, and constituents in compounds do not show their property, whereas in mixtures, they show their property. And
Okay, yes, you, Anam. The next points.
The constituents of compounds cannot be separated by physical methods like filtration, cooling, boiling, evaporation, etc. They can be separated by chemical methods, while the constituents of elements can be separated through physical methods such as filtration, boiling, cooling, evaporation, etc. In compounds, they have a fixed formula, a fixed boiling point, and a fixed melting point. Whereas in elements, they don't have a fixed formula, fixed melting point, and boiling point.
Okay, very good. Now you understood the difference between boiling and okay. Now the next one we are going to learn is the homogeneous and heterogeneous mixtures. And what is the difference between colloids, suspensions, and true solutions? Okay. So first of all, you know that homogeneous mixtures, we have learned this one, we have discussed this one, that homogeneous mixtures are those mixtures, they have uniform compositions throughout the solutions. Okay, homogenized means they have uniform composition. And the most important difference between homogeneous mixture is that when you pass light through the homogeneous mixture, then the path of light is not visible. But in heterogeneous mixtures, they don't have uniform composition throughout the solution. And okay, they don't have uniform composition, and moreover, when we pass light through it, beam of light through it, then the path of light will be visible to it. They show Tyndall effect. And heterogeneous mixtures are of two types. One is colloids, another one is suspensions. Suspension and colloids means in true solution and in colloids, they have almost same properties. Like the true solution particle is very small that it cannot be visible with naked eyes. Colloids particle will not be visible with naked eyes. True solution particles do not settle down while keeping. Colloids particle do not settle down when keeping. Okay. True solution particles true solution is also homogeneous and colloids are also homogeneous. But the main difference, that what is the main difference, that even though the particle of this true solution cannot be separated by filter, it's like you have sugar solution in water. So if you want to separate sugar by passing through the filter paper, it will not, because the particle size is so small that even if it can pass through the filter paper. So you cannot separate sugar from water or when passing through the filter paper. Similarly, if you have colloids, if you pass through filter paper, then it will not be separated. This constant cannot be separated by filter paper. But still, why they are same, having means true solution and colloids are almost having same properties, but why they are different? Why they don't have the common name? The reason behind it is that true solution, even the particle of true solution is so small that even it will not let the light particle to scatter. When light fall over it, it will not let it to scatter. Let it to scatter. Okay. So the path of light here, it will not be visible in true solution. When you pass it, the path of light will not be visible. But if you pass the same light through this one, so the path of light will be visible here. It is called Tyndall effect. What we called it? Tyndall effect. Okay. So I'm just showing you, and then you have to memorize. Then I'm going to ask you. Just a minute. Give me a second. Okay, here we have just a minute. So I'm going to give you 2 to 3 minutes. Just memorize this one. Okay. The main important is that the size of the particle may be asked, that what is the size of the particle of colloids, true solution and suspension. So you have to memorize this one properly, that the particle size is less than 10 to the power minus 10. 10 to the power minus 10 means 10 to the power minus 10 means 9 means 1 nanometer. It is also called 1 nanometer. Less than 1 nanometer. 10 to the power minus 9 is 1 nanometer. Okay. So you have to memorize this one. Just memorize it. And then let me know. When you're done, please let me know. Memorize it. Everybody keep your camera turned on. Hanan. Yes. Yes, you done? Sara, done? Bharti, Saad, Arhan, done? Samia? Speak something. You done this one or not?
Sir, don't-
Done it, done it. Take your time, learn it.
Sir, 2 minutes.
Giving you 2 more minutes. Done? Samia, done?
Yes, sir.
Hanan, you done?
Yes.
And Heather, you done? Learn it fast. Okay. Yes, you. Saad.
Yes, sir, done.
Okay. Saad, now tell me. What are colloids? What are colloids? What are colloids?
So the so the solute particles of colloids is bigger than true solution, but is smaller than suspension. In between 10 raised to minus 9 meter to 10 raised to minus 6 meter.
There is some background noise coming from your Saad. Is there something happening? Okay.
So it cannot be seen. It cannot be seen by the naked eye. It seems homogeneous, but it's actually a heterogeneous mixture. Uh, Heterogeneous mixture. It cannot be separated by filtration. It's transparent. It is also a stable solution.
Okay. Yes, you, Sarah. What are true solutions?
So the size of solute particles in true solutions are the smallest, which is less than 10 raised to minus 9 meters.
Okay.
And the true solutions are homogeneous mixtures and they are transparent
Okay.
and the particles cannot be seen with the naked eye. And
Okay.
the particles cannot be separated by filtration. And true solution can pass through filter paper as well as parchment paper. and it does not scatter the beam of light.
Okay, very good. Yes, you, Samia. What is the main difference between true solution and colloids?
So a true solution cannot pass a beam of light, whereas colloids pass a beam of light.
They both pass the beam of light. Again. Yes, you, Anam.
Sir, true solutions do not show Tyndall effect, hence they do not scatter the beam of light, while colloids show Tyndall effect, so they can scatter the beam of light.
And what is the result of scattering of beam of light?
Sir, it shows the path of the light.
Yes. When the light is when the particle is big enough, then it can scatter the beam of light. Scatter means that when light fall over its surface, it will scatter everywhere. Okay, scattering means, like for example, you have something in your hand, like sand or something, and you let it flow somewhere, so it will scatter everywhere. This is called scattering. So when the light is coming and it falls on this particle of colloid, then the colloid's particle is big enough that it can let the light particle to scatter. And when it is scattered, what happens? Hmm? Just a minute. What happens when it is scattered? Your voice is not coming, Anna. You are muted. Okay. Yes, you, Bharti. Yes, just a minute. Yes, you, Heather. Tell me that what happens if what is the main difference between true solutions and colloids? What is the main difference between true solution and colloids? So we were discussing. You were having a stomach pain. You are saying, but stomach is here and mouth is here, tongue is here. So you have to speak. Is colloid is homogeneous or heterogeneous? You unmute yourself first. Is it homogeneous or heterogeneous? Colloids.
Heterogeneous.
Hmm?
Homogeneous.
Homogeneous. Yes, you, Samia. Is it homogeneous or heterogeneous?
So it is heterogeneous.
Yes, you, Arhan. What is the main difference between colloids true solution?
Can you repeat, sir?
What is the main difference between colloids and true solution?
So, solute particles cannot be seen with naked eyes in two solutions, and the two solutions are transparent. Meanwhile, the colloidal solutions are opaque, translucent.
Okay, another difference. The main difference I'm asking. Main difference.
So, solutions diffuse rapidly through filter paper and parchment paper into solutions, and in colloidal solutions, the colloidal particles pass through the filter paper but not through the parchment paper.
Okay. Yes, you, Sarah. What is the main difference between true solution and colloids?
So the size of the solute particles in true solution is smaller, but in colloidal it is bigger.
Um, yes, you, Hanan. What is the main difference between true solution and colloids?
In true solutions, the particle size is about 1 nanometer. In colloidal solutions, it can vary up to 1 nanometer to 1000 nanometer. It cannot be seen in the true solutions. It cannot be seen with the naked eye. The same goes for colloidal solutions.
I'm asking
True
main
solution.
difference, not similarities.
Mm,
Give me a main difference.
True solutions are homogeneous while colloidal solutions are heterogeneous even though they look like homogeneous.
So why they seems to be homogeneous? Why we have, it means they seems to be homogeneous, but why we have characterized them in heterogeneous mixtures?
Mm,
Yes, you Bharti.
In true solutions, the particles do not scatter the beam of light. In colloids, they scatter the beam of light.
Yes, this is the
And-
main difference. In true solution, the particles scatter the beam of light. Do not scatter the beam of light, so the no path of light is visible. That's why we call that true solution don't show the Tyndall effect. While in in homogeneous, sorry, in colloidal solution, they the path of light is visible because they are big enough that they can scatter the beam of light. Okay. So, and what is suspension? Suspension does means what we are studying in the true solution and colloid. Like for example, true solution particle cannot be seen with naked eyes. Suspension particle can be seen with naked eyes. So it is opposite to in everything. Okay, true solutions are transparent, while solutions suspensions are opaque. Or okay, and true solution particle do not settle down. The suspension particle settle down. Okay, these are opposite. So try to write the main difference between true solution and colloids in your own words in your copy. Then I will ask. Try to write it down. The main difference between true solutions and
Main difference between which two, sir?
true solution and colloids. True solution and colloids.
Okay.
Write down three main difference, not the similarities. You done? Noted, Anam?
No, sir.
Okay. Done. Noted, everyone?
Yes, sir.
Okay. What is the definition for mass by mass percentage and formula? Anybody in the class can tell me? Mass by mass percentage formula. What's the formula for mass by mass percentage?
Mass of solute into 100 divided by mass of solution.
Very good. And the definition, what is mass by mass percentage? When X gram of solute dissolved in 100 grams of water. Okay. So if I'm going to give you question simple here. Stop. Okay, here is question number 42 on your screen. Okay, try to solve this question number 42 on your screen. Note this question number 42 and try to solve it.
Sir, done.
Okay.
No, sir.
You also done. Done, Saad?
Yes.
Hanan, you done?
Yes, sir.
Hanan, you done?
Yes, sir.
And Bharti and Sara?
Yes.
Okay, we have here. So, yes, what's your answer?
Sir, 25 grams.
25 grams.
5 grams.
25 grams.
25 grams.
So 25 grams.
Yes, anyone whose answer is not 25 grams? Bharti, what's your answer?
So I got 25 grams.
Zara, you?
Sir, I got 25 grams.
Okay, yes. Everyone, Hanan and you also? Are okay. Tell me that which of the following is not compound here. First, note it down in your copy. First, note this question. Just a minute. Question number 32. Which of the following is not the compound? Everyone first note it, solve it in your copy. Then I will ask you.
Well said.
Okay. Just a minute. Hmm. Okay, yes, tell me. Iodine is an element or a compound? Yes, you, Saad. Tell me, iodine is an element or a compound?
So it's a compound.
Iodine is compound. Is there anyone who is saying who think that Saad is correct?
So,
No, sir. I didn't.
so
It is an
element.
it is an element.
Yes, sir.
Okay. Iron sulfide. Iron sulfide is element or compound?
Compound.
Iron
Correct,
sulfide is
correct.
compound.
Compound.
Element.
Compound.
Element. Who's saying element? Iron and sulfide are two things here. Iron is an element, Fe, and sulfide is sulfur. So FeS means there are two elements that are combining together. Okay. That's why it is a compound. It is a compound. Okay. Chlorine gas. Yes, you, Sarah. Chlorine gas is an element or compound?
The compound.
Chlorine gas. Chlorine is an element, na simple element. Because if a substance is added with gas or solid or liquid, okay, then it is this is not a substance, it is a state. And chlorine is only single written. It is only chlorine. So it means that it is an element. Here there are two substances, potassium and chloride. There is a space between them. Every element is going to have only single name, and it is written in one word, not two words. If it is written in two words, then it is a compound. But think that the second word should not be any state. Like chlorine gas. Gas is a state. It is not a substance. Okay. So that's why it is an element. You understood? Potassium chloride, it is a compound because it is made up of two words. It is only single word iron. It is a, tell me, iron is
Element.
element. Element. Yes, you Hanan. Aluminium is element or compound?
Element.
Element. And this one, yes, you yeah, we have done this one. Saad, this one is element or compound? Iodine.
It's a earth element.
Element. This carbon, yes, you are
Element.
Arhan. Carbon is an element or compound?
It's an element.
Element. Okay. And this carbon monoxide,
Compound.
compound. Yes, you Hanan. Sulfur powder.
Element.
Yes, yeah. Saad. I sulfur powder is an element or compound?
It's an element.
Yeah, it is an element because powder is not a. It is a physical defining the very small particles of solids. Okay, so that's why it is an element. Sulfur is an element. Okay, and it is in powder or something crystal like it is okay, but it is in a state. Are you understood? Everyone? Yes or no?
Yes, sir.
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
Okay, in question number 19, who is correct? First, you need to tell me who is correct. And secondly, calculate here. Okay, who is correct in question number 19? Who is correct? Tell me who is correct. Oh, I changed the question just now. Question number 19 here on your screen. Now who is correct?
So C.
So student
C.
C.
The
Student-
student C is correct.
The student C is correct. Okay, now tell me that why A is incorrect. Now tell me why A is incorrect.
So because he has taken 100 ml of water, so it does not make a desired solution.
Yeah, because it has taken 100 ml of water. So it should be 100 ml of solution because it is saying mass by volume. So it should be 100 ml of 50%. A dissolve 50 grams of sugar in 100 ml of water, not 100 ml. It should be 100 ml of solution. So that's why it is incorrect. Okay. B, why B is incorrect? Yes, Anna, why B is incorrect?
Because B took 100 gram of water, whereas we have to make a mass by volume solution.
Okay. Now yeah. Even if he take 100 gram of water, uh, will it be correct for mass by mass percentage?
No.
I don't think so because for mass by mass, we need to take the mass of solution, but he has taken 100 ml or 100 grams of water.
Yeah, he has taken 100 gram of solution, not means 50 grams of NaO should be in 100 gram of solution, not in 100 gram of water. Okay. Okay. Now C is correct because he has taken 50 grams of NaO to make it 100 ml of solution. So C is correct. Okay. Very good. Proud of you. Next. Okay, here we have both smoke and fog are aerosol. What is the difference between them? What is the main difference between them? Both smoke and fog are aerosol. In what way they are different? Tell me in what way they are different?
Smoke's dispersed phase is solid and fog's dispersed phase is liquid.
Yes, fog is liquid, gas dissolving liquid. Sorry, liquid dissolving gas. Okay, like water particles, water droplet dissolve in gas. So it is fog. And when solid particle like unburned carbon particle get dissolved in air, it forms smoke. Okay, so there is a difference between the uh, dispersal phase. Okay, so that's all for today. We'll meet you in the next class. Thanks for coming, everyone.
Thank you, sir.
Thank you, sir.
Bye. Take care. Yes, Mariam, how are you? Just wait for 2 or 3 minutes so that the student will also join.
Yes, sir.
Till then, Mariam, revise the preparation of salts. We have done the salts, no?
Yes,
We,
sir.
we did baking soda, caustic soda, and we did baking soda. No. We did bleaching powder and baking and NaOH, na? In the previous class.
Sir was not there last class.
It was not there in the last class.
Yes, sir.
Okay, why you were not there in the last class?
Sir went out.
You were at outside.
We went out. Yes.
Okay. You are in Dubai.
Last class we were. No, sir, we went to Dibba.
Right now, in which country you are?
No, now we are in Dubai. Yeah.
You are in Dubai. Okay.
Sir, I'll watch the recording.
Then watch the recording. Okay. Okay, Zainab and Mariam, you both please turn on your camera. I'm just going to write the preparation of salts and you have to memorize it. That we have discussed in the previous class. Okay, I'm just writing here that how we can prepare caustic soda. So caustic soda can be prepared by passing electricity to brine. Brine is a mixture of sodium chloride and water. This is brine. We pass electricity to it, it will gives you NaOH, which is called caustic soda or sodium hydroxide plus hydrogen gas plus chlorine gas. This hydrogen gas is produced at an cathode and this chlorine gas is produced at anode. Second preparation is bleaching powder. Bleaching powder can be prepared by passing chlorine gas to slag lime. Slag lime. When you pass chlorine gas to it, it will give you CaOCl2, which is called bleaching powder. Plus water. Check in the previous class, Zainab, we have done the do we have done the baking soda also?
Yes, sir.
Yeah. So baking soda can be prepared by passing
We started a new chapter later.
which chapter we started?
The first one, chemical equations, and
No,
yeah.
no. That was the backup class of yours. So
Oh,
this is the continuous class today. NaOH, sorry, we have how can we prepare baking soda? Baking soda can be prepared by passing. This is bleaching powder, okay? And baking soda is NaCl and water plus ammonia gas, NH3 plus carbon dioxide. When we pass through it, it will gives you NaHCO3, NaHCO3 plus Cl plus ammonium chloride. Ammonium chloride. So this is baking soda. This is baking soda.
Sir, caustic soda and the common salt is same.
Caustic soda and the common salt is not same. Common salt is NaCl and caustic soda is NaOH.
Okay, sir.
So memorize this all three equations. I'm going to take your test. When you're done, write down it 2 or 3 times in your copy, because you will not be able to do anything if you are not able to memorize it properly. Yes, Juliet, turn on your camera. Juliet, this is written the preparation of 3 salt that we have studied in the previous class. One is the preparation of caustic soda. Second is the preparation of bleaching powder. And third is the preparation of baking soda. Okay. The first process